I think we're good. So I have an exponent outside parentheses. What do? Multiply each exponent. So I have a to the 1 times m, or a to the m, b to the 1 times m, or b to the m. For example, if I have 3, which has an exponent of what? 1. The x has an exponent of 1. So I'm going to have to multiply each exponent by 3. 3 to the 1 times 3 is 3 cubed. X to the 1 times 3 is x cubed. If you want to multiply it out, have at it. Negative exponents. You remember negative exponents. If I have a negative exponent, how do I get rid of it? Okay, everything is over 1. A whole number is always over 1, right? If it has a negative exponent, all I have to do is flip it and make the exponent positive. Now, be careful. A cannot equal 0 because you cannot have 0 in the denominator of a fraction, right? For example, if I have 5 to the negative first power, think of it as 5 to the negative first power over 1. Flip it, I get 1 over 5 to the positive 1, or 1/5. Same thing if I have a negative exponent in the denominator of a fraction. What am I going to do? Huh? Yeah. Again, it's actually, it might be pre-old. No. I have 6 to the first over 1, which is just 6. Anything raised to the 0 power is what? 1. If I'm dividing or have a fraction dividing with the same base, what do I do with the exponents? Subtract. So in the first one here, I have 2 to the 8 minus 5, which is 2 cubed. If you want to multiply it out, it's 8. The next one is 3 to the 4 minus 7 is 3. Careful. Is negative 3, right? I could never leave my answer with a negative exponent. So what is this? 1 over 3 cubed, or 27. And the last property, power of a quotient. If I have a fraction or division, a over b, with different bases, I have to distribute that. It's really not distributed, but I'm going to distribute that exponent to each of the exponents of the fraction. Okay? I don't know what you mean by splitting. I don't know. I don't know what you're asking me. So hang on until we get some examples. All right. All right. So a to the 1 times m is a to the m. B to the 1 times m is b to the m. Example problems. Again, if they don't have an exponent, it's 1. So I have 2 to the first. 1 times 4 is 2 to the fourth. 4 times 1 is 3 to the fourth, or 16 over 81. Questions about the properties? Again, this should all be reviewed for you guys. First example, I have r divided by s to the negative 5 raised to the power of 2. I'm going to put my exponent there so I don't screw it up. Okay, it's outside parentheses, so I'm going to multiply each exponent. I get r to the 1 times 2 is 2, divided by s to the negative 5 times 2 is negative 10. I can never leave my answer with negative exponents. So I need to move this upstairs, right? R squared s to the 10th. If you want to put it over 1, fine, or just leave it as it is. Okay, second example. I have a couple of things going on here. First of all, I'm going to put 1s for the exponents, just so I don't make a mistake. And it looks like I have a power to a power, so parentheses with different bases. So I'm going to multiply the exponents. So I get 7, 1 times 2 is 7 squared. B to the negative 3 times 2 is negative 6. B to the 5th. And B to the 1st. Now, this is all multiplication here with the same base, right? What do I do with the exponents with the same base? You combine them or add them, right? 7 squared is 49, or you can leave it 7 squared. I don't care. Negative 6 plus 5 is negative 1 plus 1 is b to the 0, which is just 49. Third example. See, I'm going to go ahead and put my 1's exponents there so I don't make a mistake. I have a power raised to a power. I'm going to need to multiply those. So I have I to the 1st, z to the negative 2, x to the 2 times 3 is x to the 6. Y to the 1 times 3 is y cubed, and then z to the 1st. Now, back in Algebra 1, they may have taught you to go ahead and group our variables together. This helps if you have really long problems. Y to the 1st times y cubed, and z to the 1st times z to the negative 2. It just kind of helps organize things. If you want to do that, by all means, go ahead. Writing on my desk. Nice. Yes. Okay, so I get x to the 6. Y to the, since my y's are the same, I just add the exponents. Y to the 4th. Z to the 1 plus negative 2 is what? This is z to the negative 1. Now, I can't put that in my answer because I can't have negative exponents. Where does it go? Yeah, I'm going to have to make the fraction and put it in my denominator. I don't know. 3 to the 1st. I have negative 4 outside parentheses, so I need to multiply to each exponent. So I get 3 to the 1 times negative 4, 3 to the negative 4, x to the 3 times negative 4 is x to the negative 12, and y to the negative 2 times negative 4 is positive 8. Sorry. See, I'm going to have to make a fraction out of this because I have negative exponents. So 3 to the 4th is going to go in the bottom. x to the negative 12. I'm going to make it positive, put it in the bottom. Y to the 8th is positive. I'm going to leave it in the top. Isn't this fun? Next one. I'm going to go ahead and put an exponent of 1 with my x. I have a power raised to power. I have x to the 1 times 2 is 2. Y to the 2 times 2 is y to the 4th. X cubed, y to the negative 1. I have x squared divided by x cubed, so same base in a fraction. What do I do with the exponents? X equals what? Yeah. 2 minus 3 is negative 1, so it's going to stay in the denominator, make it positive. 4 minus negative 1 is 5, so y to the 5th is going to be numerator. I don't have any powers to a power, so I'm just going to subtract the exponents. X to the 4 minus negative 3 is x to the 7th. Going to leave it in the top. Y to the 3 minus 0 is y cubed. Leave it in the top. If you want to put a 1 there, that's fine. Otherwise, just x to the 7th, y cubed. Next one. 12 divided by 8. Can't be done. Well, it could, but you get a decimal, right? So let's just make sure it's simplified. What factor goes into both of those? That's right. 12 divided by 4 is 3. 8 divided by 4 is 2. Or you could just put it in your calculators and hit math. X to the negative 5 minus 6. X to the negative 11. Where's it going to go? That's right. Denominator. Make it positive. Y to the 7 minus 4 is 3. Stays in the numerator. Now I say, look at those last 3 problems. Can you guys see a pattern here? Can you? What? Huh? Look at the bases and then look at the exponents. No? No. I thought somebody had it. Now, are you going to put that, are you going to throw it away? You're going to make me clean up the room after this hour. All right, let's look at this. In my problem here, I have x squared and x cubed. Which one's larger? The x cubed, right? Where did my x end up? In the same place as the larger exponent. Yes, sir. Yes. Y to the 4th over y to the negative 1. Which one's the larger one? Y to the 4th. Where did my y end up? In the same spot as the larger exponent. If you're having trouble where to put the x or your y or your variable, just look at the original problem. X to the 4th, x to the negative 3. You know your x is going to be in the numerator because the 4 is larger than negative 3. Your exponent for y is 3. Your exponent for y is 0. You know your y is going to end up in the numerator in the answer. Get it? Did you find that exciting? Wow. It's more fun stuff for super fun week of homecoming, right? Super homecoming week. Fun. You guys remember how I canceled things out before I meant multiple fraction? Let me show you one problem. Nobody's going to end up doing it because they always get confused. All right, let's look at the next one. You can always cancel out stuff before you multiply, which is what you guys should be doing, because when we get to rational expressions, you need to do that. Okay, 2 goes into 20 how many times? That's right, 10 times. 2 goes into 2 once. Let's see, there's 8 x's here. There's 14 there, so I can take 8 out and get x to the 6th, right? There's another x to the first here, so I can take another x out and get x to the 5th. And then I've got 6 y's down here. These all turn to 1. I got 10 up there, so it leaves me with 4. Then multiply across. I got 10 x to the 5th, y to the 4th on top. And if you want to put it over 1, that's cool. I don't care. So if you know how to cancel out, it actually makes your life easier. You look really happy to. And I never would have guessed. And the last problem I'm doing, I'm going to put my 1's in for my exponent so I don't make mistakes. -3 times 2 to the first will be 2 to the -3. -3 times x to the first is x to the -3. -3 times 2 is going to be y to the -6. Never leave negative exponents in your answer, so I'm going to flip everything. Y to the 6th, 2 to the 3rd, or you can multiply it out to 8 over x cubed. In your book, try doing this about 4 or 5 times a day. Now, on the front of